All right, guys, welcome back. We're going to do some more weird math. This is quiz 12. This is 12J. If you guys want to take a look at the computer screen, print it out, follow it along with. We're going to talk about this chapter. This chapter is titrations with strong acids and strong bases. So this first quiz, the chapter is acid-base titrations. This first quiz concentrates on strong acids and strong bases. And as you may remember from general chemistry, when you react a strong acid with a strong base, what happens, I'm going to move this over, so we're going to write it out. Say you've got sodium hydroxide. Okay, when you put that in water, it's going to fully dissociate. So you're going to have Na plus and you're going to have OH minus. All right, sodium is a spectator. It does not do anything in the acid-base neutralization. But if you're adding sodium hydroxide and hydrochloric acid, so hydrochloric acid is a strong acid, sodium hydroxide is a strong base. This is going to dissociate into H plus and Cl minus. Okay, so when you react this together, you're going to get water and salt. So these two are going to come together to make water, and these two are going to come together to make salt. All right, we don't really care about the salt. What we're concerned about are these two species right here. And when you have equal moles, so equal molar amounts of acid and base, so here's your acid, here's your base. When you react them together in equal amounts, you get a neutral solution, which is pH 7. Every single one of these quizzes that I have gone through asks you what the pH is at the end point, which he uses endpoint and equivalence point interchangeably. They're not technically interchangeable terms, but he uses them that way on these quizzes. All right, so now that we've just kind of touched on it briefly, let's take a look at this, and we're going to go through these problems. So part 1, we have got a strong base reacting with a strong acid, and we are asked to calculate the equivalence volume of added hydrochloric acid. So we've got our reaction up here, and then it gives you the amount of base. So the formula we're going to use, I'm going to tilt this a little bit so I can write, is we're going to do the molarity of your acid times the volume of your acid over the number of moles in your acid. And we're going to set that equal to the molarity of your base times the volume of your base over the number of moles of your base. Now you can do this with like unit conversions where you take in your molar ratios and all of that good stuff. This is just, one and done, easy equation, and it makes more sense to me, so this is what I use. You can use whatever you want and whatever makes more sense to you in your mind, okay? So we're going to sub this in. We are looking for the equivalence volume of our acid, so this is what we're looking for, and we should have everything else. So, and on these, whatever units you're looking for, make sure that they match. So if you want your volume in milliliters, then you can use milliliters. If you want it in liters, make sure that both volume units match on these equations, right? Because if they match, then they'll cancel if you're solving for molarity. But if they don't match, then you're going to get really weird numbers and nothing's going to add up. Anyway, on with it. Let's sub in some numbers. So the molarity of our acid. Okay, so this is our acid, and then we're trying to find our volume. Now, these, we don't really actually have to worry about the number of moles because it's 1-to-1. But if we had different stoichiometric coefficients here, then you would need to worry about your N number there. Okay, but as it's 1, we don't really need to worry about it. But we're going to set this equal to our base volumes. So we have got 0.07139 times, and I'm just going to leave it in milliliters, 30 milliliters. And we're solving for VA. So we're going to divide both sides by our molarity And then that is going to give us a volume of 25.01 milliliters, right? Easy peasy. So now it's going to ask us, part B, what is the pH before the addition of any acid? So this is asking us what the pH of this amount of this molarity of potassium hydroxide is. And that's really easily, because if you remember, potassium hydroxide dissociates into OH negative and potassium. So we are going to first find our POH, because we've got our molar amount here of potassium hydroxide. So we're going to do the negative log of 0.07139, because that's our molar amount here. And that is going to give us 1.146. Now to go from POH to pH, then you're just going to take your pH is equal to 14 minus your POH, 1.146, and that is going to give us a pH equal to 12.85. I like to box my answers in because I feel like it makes it look neater. Okay, so this is the question that I've talked to you about at the beginning of the video that I have seen on every single one of his quizzes so far that I've looked at for this section. Calculate the pH at the end point of the titration. He uses end point and equivalence point interchangeably, but what he's saying is that your moles of your acid is equal to the moles of your base, okay, because it's a strong acid, strong base, and this pH is always going to be 7. Okay, for strong acid, strong base, at your equivalence point, your pH is 7. Now, if you have a weak acid and a strong base, your pH is not 7. If you have a strong acid and a weak base, again, if one of them is strong and one of them is weak at equivalence point, it's not going to be 7. But strong and strong it is. Now, the last section is a little bit more complicated because it's asking us to find the pH at a point other than the equivalence point. So we are going to have to kind of pull back some tricks that we learned earlier in the semester in dealing with the fraction of the remaining. Okay, so right here we're going to say calculate the pH of 10 milliliters of the 0.08564 molar hydrochloric acid. Now, we've got to get into moles on both of our acid and our base. We have to have them in moles to be able to calculate what's remaining. Okay, so we're going to start with our acid because we've got that right here. So 10 milliliters is 0.010 liters, and we're going to multiply that by our molarity. And this is kind of what I do just to keep it straight in my head, because your units are going to cancel there, and then you're going to be left with moles, right? So when we put this into the calculator, that's going to give us 0.0008564, right? Sounds good. And then we're going to come down here, we're going to do the same thing with our, and this was our acid. Keep that one straight, all right? And our base, let's come back up here. So we had 0.030 liters times 0.07139 moles per liter. And that is going to give us 0.0021417. I am keeping extra digits. Oops, I don't know if you guys could read that. I am keeping extra digits, and I'm going to round at the very end. Sometimes with these calculations, that can mess you up and give you a slightly different number. But usually, if you stick with your significant figures, you're okay. Now, what we've got to do now is we've got to do our remaining, like see how much we have left. Because we know at our equivalence volume, right, for our hydrochloric acid. In order to reach equivalence with this much base, we have to have 25.01 milliliters. Well, we don't have that, so we know that we're not going to be at equivalence point. So we've got to see how much of our potassium hydroxide is left so that we can find out what our pH is. Okay? So our remaining is going to be, and we're going to subtract our smaller number from our bigger number. And hold on just a second. All right, so now let us set this up here. Okay, so we have on our top, we're going to take our larger number and we're going to subtract the smaller number from it. So that is going to be 0.0021417, and then we're going to subtract our other number. And then we're going to figure out what our total volume is here. We're going to need that in just a minute. But we've got to figure out what this subtracts out to be, because we are going to divide that by our total volume. And so we're doing 10 milliliters here, 30 milliliters here. So it's 10 milliliters. And we're going to add that to 30 milliliters. Okay. Now this is going to give us 0.0012853 moles of KOH in 40.04. We're going to go ahead and put it in liters. 0.040 liters of solution. Now, this is our hydroxide concentration. So that's going to give us a hydroxide concentration of 0.03213. Okay. And now we know that hydroxide concentration, in order to get to pH, we're going to do the negative log of this for our POH. And that is going to give us a POH of 1.493. And then we are going to subtract that from 14 to give us a pH equal to 12.51. And that is our final answer. So this quiz I don't think is going to be too terribly difficult, as long as you remember that you've got to convert this to moles, and then you have to divide it by the total volume of your solution. And as long as you remember to do that, you should be pretty good on this one. Let me know if you have any questions, and good luck. Okay, one other thing before I forget that I did want to mention. So in a couple of these quizzes that I've seen, this is 12M, for example. The very last portion asks what the initial concentration of the sample is in ppm of Br. Okay. Now, remember that ppm is equal to milligrams per liter. Okay. So you're going to take your concentration of this one, I think is hydrobromic acid up here, and you're going to do your unit conversion to go from HBr down here over to bromine, right? So you have to take into account your molar ratio, which is 1:1. Then you have to go from moles to grams, and then grams to milligrams. And when you've got it in milligrams per liter, then that is your ppm, and that is parts per million. And the other one that was unique that I think is worth mentioning here is we have got part C. In this one, we are dealing with hydrochloric acid and lithium hydroxide. it asks what the concentration of lithium in the sample is in milligrams of lithium per liter. All right, so remember how to do your unit conversions on that. So we're going to go from lithium hydroxide, and then we're going to convert that from that to lithium. Okay, so the number of moles, and then you've got to go from moles of lithium to grams of lithium, right? So you need your gram weight there, and then you've got to go from grams to milligrams. All right, to get your gram weight, your concentration in milligrams of lithium per liter. So you're already in, like, when you've got your molarity, you're already in moles per liter. So you just have to go from moles to milligrams. All right, so just don't forget how to do your unit conversions, and you should be good on this one. Those are the only things that I saw that were unusual. Again, let me know if you have any questions, and I'll talk to you later.